Let us talk about odds in favor of an event. So let E be an event such that the probability of the complement of E will not be equal to 0. Then the odds in favor of event E are defined to be the ratio between the probability of event E and the probability of E complement. So let's have this example. Suppose that a coin is weighted such that the probability of getting ahead is 0.65. What are the odds of getting ahead when a weighted coin is tossed? So we are given that the probability of getting ahead is 0.65, which would mean the probability of not getting ahead is 1 minus 0.65 or 0.35. This would mean that the odds, let's just use letter O to symbolize the odds, would be 0.65 over 0.35. If we perform this operation in lowest terms, we're going to get 13 over 7, which means the odds in favor of getting ahead in this weighted coin is 13 to 7. It's pretty big because it's almost half of the not getting ahead happening. So, another example. Suppose that the probability of winning the next basketball game is 0.48. What are the odds of winning that next basketball game? So the probability of winning is 0.48. The probability of not winning is 1 minus 0.48, which is 0.52. So the odds would be 0.48 over 0.52, which in lowest terms would be 12 over 13. So the odds of winning the next basketball game are 12 to 13. It's a bit close, but it's a bit unfavorable when you want to win that basketball game. Now, we know that because of that definition of the odds, we are given with this theorem. Let E be an event such that the odds in favor of E are M to N. That is, the probability of E over the probability of E complement is equal to M over N, where we know N should not be equal to 0. Then, the probability of E would be M over M plus N, and the probability of E complement would be N over M plus N. Which in a way would make sense because the probability of E would actually be usually the cardinality of E, which is that M over the cardinality of E union E complement. So this is true. For example, the odds in favor of winning a bingo game are 5 to 17. Pretty low. What is the probability of winning the game? So we know that the odds are 5 to 17. So we can write that as that 5 over 17. So the probability of winning, we can use this formula here. The probability of winning would be 5 over 5 plus 17, which is 5 over 22, which would be 0.2273 in decimal and 22.73%. So it's a pretty low chance of winning, only around 20%. That's why your odds of winning are 5 to 17. Let's have another example. A card is drawn from playing a standard deck of playing cards. Find the odds in favor of drawing a red 10 and find the odds in favor of drawing a queen or a black card. Pause the video and try to see if you'll be able to find these odds. Alright, so first we are asked to find the odds of finding a red 10. So we know that there are two red 10s, a 10 of hearts and a 10 of diamonds. So there. So the probability of getting a red 10 would be 2 out of 52. And that would mean that the complement of that would be 1 minus 2 over 52, which is 50 over 52. So therefore, the odds would be 2 over 52 over 50 over 52, which is 2 over 50. Or, in lowest terms, 1 over 25. That would mean that you have a 1 to 25 chances or 1 to 25 odds of drawing a red N. How about now drawing a queen or a black card? So number 2, a queen or a black card. We know that there are 4 queens. So we have your queen of, that would be the queen of clubs. Yeah, sorry for the bad drawing. The queen of spade, then the queen of hearts, and the queen of diamonds. And black, we know that there are 26 black cards because there are the clubs and the spades are black. And there's 13 each suit, so that's 13 times 2, 26. We know as well that these two also belong to that 26. So the total count here would be 26 plus these 4 minus this 2, which is an example of the inclusion-exclusion principle. So therefore, we're only going to have 28. This is the this is the cardinality rather of the event that we need. So let's bring that up. The probability of having a queen or black card would be 28 over 52, which would mean the probability of having the complement of this would be 1 minus 28 over 52, which is 24 over 52. So therefore, the odds would be 28 over 52 over 24 over 52, which will give us 28 over 24, or in lowest terms, 7 over 6. So the odds of getting a black or a queen would be 7 to 6. That's pretty big. So here are examples of odds in favor of an event.